The universe is vast. It's filled with billions of galaxies, each containing billions of stars. But does it go on forever? The question of whether the universe is infinite or has an edge is a fundamental one that has puzzled scientists and philosophers for centuries. It's a question that takes us to the very edge of our understanding of the cosmos. Looking up at the night sky, we see a tapestry of stars, a seemingly endless expanse. The sheer scale of the universe can make the idea of an edge seem absurd. After all, if there is an edge, what lies beyond it? The concept of infinity is difficult for our human minds to grasp. We are used to things having boundaries, to limits and edges. Can something truly exist without any boundaries at all? The answer, as with many things in cosmology, is complex and still debated. However, by exploring the concepts of the observable universe, expansion, and theoretical models, we can begin to unravel this cosmic mystery. To understand the question of the universe's size, we need to first consider what we can actually observe. The observable universe is the portion of the universe that we can currently see from Earth. It's a sphere with a radius of about 46.5 billion light-years. This doesn't mean that the universe ends at that point. It simply means that light from beyond this distance has not had enough time to reach us since the Big Bang. The universe is about 13.8 billion years old, so we can only see objects that are close enough for their light to have traveled to us in that time. Imagine standing on a ship in the middle of the ocean. You can only see a certain distance to the horizon. The further away a ship is, the longer it takes for its light to reach your eyes. Similarly, the observable universe is our cosmic horizon. The observable universe is constantly expanding as more light from distant regions reaches us. However, this expansion doesn't mean we are approaching an edge. It simply means we are seeing more of the universe as time goes on. The universe is expanding. This doesn't mean it's expanding into something else, like a balloon expanding into the air around it. Instead, the fabric of spacetime itself is stretching, carrying galaxies along with it. Imagine raisins in a loaf of bread dough that is rising. The raisins themselves are not expanding, but the space between them is increasing. This expansion has led some to believe that the universe must have an edge, a point beyond which this stretching stops. However, this isn't necessarily true. The universe's expansion doesn't require a boundary. Consider a flat sheet of paper that is infinitely large. Now imagine that this sheet represents the universe. If you were to draw dots on the paper to represent galaxies and then stretch the sheet in all directions, the dots would move further apart. This would happen uniformly across the entire sheet, even though there are no edges to this infinite sheet. Similarly, the universe could be infinite and still be expanding. The expansion itself doesn't tell us whether or not the universe is finite or infinite. It simply tells us that the space between objects in the universe is getting larger. One possibility is that the universe is finite but unbounded. Imagine an ant walking on the surface of an orange. The ant can walk in any direction and never encounter an edge. However, the surface area of the orange is finite. The universe could be similar, existing as a closed, curved surface. If you were to travel in a straight line in this type of universe, you would eventually end up back where you started. This concept is difficult to visualize, but it arises from Einstein's theory of general relativity, which describes how gravity warps space-time. Just like the ant on the orange is unaware of the third dimension, we might be unaware of higher dimensions that would allow the universe to curve back on itself. This curvature could be so subtle that we haven't been able to detect it yet. Section 5. Beyond the sphere, hyperspheres and hyperdonuts. While the concept of a curved, finite universe is intriguing, it becomes even more mind-boggling when we consider higher dimensions. Mathematicians and physicists have proposed even more complex shapes for the universe, such as hyperspheres and hyperdonuts. A hypersphere is a four-dimensional sphere. Just like a sphere is a curved surface in 3 dimensions, a hypersphere is a curved surface in 4 dimensions. It's impossible to fully visualize a hypersphere, but we can use mathematical equations to describe its properties. A hyperdonut, also known as a 3 torus, is another theoretical shape for the universe. Imagine a donut, but instead of having a 2-dimensional surface, it has a 3-dimensional surface that curves back on itself in a 4th dimension. These shapes might seem like something out of science fiction, but they are serious contenders in the quest to understand the true nature of our universe. Section 6. Navigating the hyper-universe size and shape. Determining the size and shape of the universe is an ongoing challenge. Scientists use various methods such as studying the cosmic microwave background radiation, the faint afterglow of the Big Bang, and the distribution of galaxies to try to measure the curvature of the universe. If the universe is finite and curved, like a hypersphere or a hyperdonut, then its size would be finite as well. However, if the universe is infinite, then its size is, well, infinite. The shape and size of the universe are also linked to its ultimate fate. A closed universe, like a hypersphere, would eventually collapse in on itself in a big crunch. An open universe, on the other hand, would continue expanding forever. Section 7. The Infinite Universe, Implications and Possibilities. The idea of an infinite universe is both awe-inspiring and daunting. If the universe is infinite, then it contains an infinite amount of matter and energy. This means that everything that is physically possible must exist somewhere within its vast expanse. An infinite universe would also have profound philosophical implications. For example, it would mean that there are an infinite number of copies of ourselves out there, living out every possible variation of our lives. While the concept of an infinite universe is difficult to wrap our heads around, it is a possibility that we cannot rule out. The universe is full of surprises, and it's entirely possible that it extends far beyond what we can currently observe. Section 8. Infinity and Beyond. The universe's unending mysteries. The question of whether the universe is finite or infinite is one that has captivated humankind for centuries. While we have made significant strides in understanding the cosmos, this fundamental question remains unanswered. Whether the universe is a finite sphere, a complex hyperdonut, or stretches on forever, one thing is certain: the universe is a place of wonder, full of mysteries waiting to be uncovered. The pursuit of knowledge about the universe's size and shape is a journey that will continue to inspire and challenge us for generations to come.